Okay, let's start with our first example. We're given f prime of x is equal to x squared times x minus 1 over x plus 2. And here x is not equal to negative 2. So that's not part of the domain. So in order to find the critical points, we have to set everything equal to 0. So that involves setting everything. So each factor equal to 0. So the top is the 0 part, the bottom is the undefined. So remember, the critical points, not only when the function is 0, when the derivative is 0, but it's also when it's undefined. Okay, so we get x equals 0, 1, and negative 2. Okay, now when f is increasing, f is decreasing. Well, let's look at the number line test, the first derivative test. So here we can just rewrite the derivative. We know that x squared is always greater than or equal to 0. So this is really x minus 1 over x plus 2. And in the long run, this is just 1. So we know at the endpoints it's going to be positive. And so we just need to test, let's say, negative 1.5. And we see that it's negative in those regions. So my function is increasing, decreasing, decreasing, and increasing. So it's increasing from negative infinity to negative 2, and from 1 to infinity. It's decreasing from negative 2 to 0. And here we have to skip over 0 because the derivative there is 0, but we want it to be positive. I'm sorry, we want it to be negative for decreasing. Okay, and so obviously at negative 2, there's a max, and at 1, there's a min. But we said x cannot equal negative 2 over here. So we're going to ignore this. That is not a max. Let's look at the next example. We have the derivative is x minus 2 times x plus 4 over x plus 1 times x minus 3. X cannot be negative 1 or 3. So for the critical points, we're setting each factor equal to 0, and we get 2, negative 4, negative 1, and 3. Now let's see where the function is increasing and decreasing. So this one we need the number line, so the first derivative test. Our critical points we said were negative 4, negative 1, 2, and 3. And then we just rewrite the derivative. Actually, let's go back. So the derivative, x minus 2 x plus 4 over x plus 1 x minus 3. Yeah, so we're just going to test the different regions, but first we know that this is basically x squared over x squared, which is 1 in the long run. So for the endpoints, we know it's going to be positive. And then it's just a matter of, testing these different regions. So when we do that, we see that it's alternating. And so the derivative is positive, negative, positive, negative, positive. So f is increasing, decreasing in that pattern. So for increasing, we're going from negative infinity to negative 4, negative 1 to 2, and then 3 to infinity. decreasing from -4 to -1, and then 2 to 3. Remember here, we said x cannot equal -1 and 3. So these guys are not going to be part of it. So we're going to ignore them and see, okay, at -4 there's a max, and at 2 it's also a max. Okay. All right. Last problem. F prime of x is 1 minus 4 over x squared, and here x cannot equal 0. So a lot of students here would just say, okay, well, we'll just do 1 minus 4 over x squared equals 0 and call it a day. But there's actually a really nice way to deal with this problem. We're going to get a like term. I'm sorry, we're going to get a common denominator. So we're going to multiply this by x squared over x squared. So we'll get x squared minus 4 over x squared. And then we're going to set this equal to 0. And when it's undefined. Right? So the 0 part is always the numerator. Undefined is the denominator. So if we set x squared minus 4 equal to 0, we obviously get that x is equal to plus or minus 2. And if we set x squared equal to 0, we get x is 0. Okay, so now we can, these are our critical points first of all. Right, so those are critical points. And now we can use a first derivative test to classify them. So we know that the derivative is 1 minus 4 over x squared. Okay, so in the long run, 4 over x squared is 0. So the limit here is positive 1. So therefore, that's going to be positive. If we test in between these regions, we get that they're both negative. So it's going to be increasing, decreasing, decreasing, and increasing. So f is increasing from -infinity to -2. And then from 2 to infinity. F is decreasing from -2 to 0. And then we have to skip over 0 because the derivative is equal to 0 there. Or rather, undefined actually in this case. So yeah, we can't include it. And then from 0 to 2. Last step is to classify the max and min. This is a maximum. And then this is a minimum.